Hi, today we're going to be talking about Lewis structures. Lewis structures can be used to show what happens between different chemicals, using something as simple as dots. In this example, an ionic compound, we see sodium and chlorine. Lewis structures can be used to write ionic and molecular compounds. Ionic compounds deal with a metal and a nonmetal. If we look at this example, we can see that the single dot on sodium represents 1 electron in its outer shell. Chlorine, on the other hand, has 7, so it has 7 electrons in its outer shell. Due to the octet rule, both of these would rather have 8 than 7 or 1. In this case, with an ionic compound, sodium can transfer its single electron to chlorine, giving it 8 and getting rid of its 1. After the transfer has taken place, we write a plus next to sodium, meaning plus 1, because it was oxidized and lost an electron. Chlorine, on the other hand, gained an electron and was reduced, so it has a -1 charge. As you can see, chlorine in brackets has 8 in its outer shell, so both are happy. Hi, my name's Ray.
I'm Lisa.
And we're going to be talking now about molecular compounds. Molecular compounds have a different type of relationship than ionic compounds. Rather than transferring electrons, they will share electrons between themselves in order to reach the optimal amount. In this case, we see hydrogen and fluorine. Hydrogen is unlike most atoms because hydrogen only wants 2 electrons in its outer shell. However, fluorine, like most, wants 8. Hydrogen only has 1, and fluorine has 7, so both need 1 electron in order to reach their optimal number. In that case, they will form a single bond. In the single bond, they will each share electrons. Therefore, hydrogen will share its 1 with fluorine, and fluorine will share 1 of its own with hydrogen. This gives them 2 shared between them, so hydrogen will have 2, and fluorine will have 8, 6 of its own and 2 shared. Another type of bond is a double bond. This can be seen with 2 oxygen molecules. Oxygen has 6 in its outer shell, so it wants 8. In this case, oxygen can actually share 2 of its electrons rather than 1. If it only shared 1, it would have 5 of its own and share 2 in between, giving them each 7. However, if it shares 2, which can be shown by a double bond, they will each have 4 of their own and share 4 in between, giving them both 8. They can also share triple bonds, which is stronger and shorter than a double bond, which is also stronger and shorter than a single bond. Among these, the triple bond is the shortest and the strongest. This can be seen with certain polyatomic ions. When writing the Lewis structure for a polyatomic ion, remember that the ion itself can have a charge, which must be factored in with the electrons. We see that carbon has 4 electrons, nitrogen has 5 electrons, and the polyatomic ion, Cn, has a -1 charge. Therefore, 4 plus 5 is 9, and coupled with the -1 charge gives it 10 electrons total. With 10 electrons, these 2 molecules will actually form a triple bond. By doing so, if you keep 2 with each nitrogen and carbon, they will have 2 of their own and share 8 in the middle. If we do that, creating a triple bond, we have 6 shared between us and 2 each, which accounts for the whole 10, but gives each the octet of 8.